depends on which is a good sign. All right, so yesterday we started talking about how after the first derivative, there's a second, and a third. Is there the infinite derivative? No, because infinity is not a number.
Yes.
So what we'll do today is we'll finish this second example. And I think what is nice with this example is this really does a good job of wrapping together what we've learned in this lesson and what we've looked at with like implicit differentiation, because we have to use that skill. But like our quiz, which will be tomorrow because I'm not going to push our test to Monday. The quiz tomorrow will be over this lesson and what we did last week with inverses. So what is nice is that you can write, that first and second derivative, but what will be worth seeing here is that there will be at times where a second derivative is written in terms of x, y, and the first derivative. So we're going to see how we can clean things up and stuff like that. So given this circle with a radius of 5, we're going to find the second derivative where we are just dealing with x and y. Okay, so we should know that this second derivative will use some implicit differentiation, right? That's our first step. I'll put that here. And if you want to put y prime, that's fine. Now we'll have to solve for that dy dx. Okay. I've never tried taking the second derivative from this expression, just because if we solve for dy dx, it just becomes a lot simpler. So I subtract that 2x, subtract that 2x. So I have 2y dy dx equals negative 2x. Then I divide by the 2y. So negative 2x over 2y is negative xy. Negative x over y. So there's the first derivative. Now what we'll need to do is we will need to take the derivative of this derivative. There are a few different ways we could do this. Since it's already written as a quotient, might as well just do the quotient. So we take the derivative of each side with respect to x, and now we're going to get that second derivative. So we do low, which is y, d high, so negative x, the derivative of negative x is negative 1.
I know what you meant. Why you said don't ask me why the d is squared in the...
Oh, up above?
Yeah. It's because you're multiplying d times dy.
That's
dx times dx.
That
Oh, you're spinning.
that might be why.
That's,
Yeah.
Yay! I was really excited about that. Something finally clicked in my brain.
Oh, more than one thing.
I know. Well, right about that. Yeah.
All right. So low d high minus high d low. Now the derivative. So this is where it becomes a little tricky. you're taking the derivative of y. So that is where we get dy dx. Okay. Now, technically, it is 1 dy dx. But, right, we normally don't write that one. And this is divided by y squared. Right, it's because it's the bottom squared. Now, this is where our algebra skills, just like with the other problems that we've been seeing up to this point, really becomes important. The problem says to write this in terms of x and y. Now, here's how we're going to do that. I already know that dy dx is negative x over y. So let's, so this went to here. We're going to bring this kind of down here like this. Okay. So this is negative y plus x times negative xy. Because that's what dy dx equals. It's negative x over y divided by y squared. Now, I have an expression up here. How am I going to combine well, what do I need to do with this numerator to make it look simpler?
Combine it.
Yes, but how am I going to do that? Because I can't just, if this is a fraction over here, if I have a fraction over here, what do I need to add something and a fraction?
Yeah. Wait.
A common
Denominator.
denominator. So I have divide by y here, divide by y, which just means that this is y squared. Because it's going to be y times y. So then this will become, I'm going to write this a little bit differently. So this is negative y squared minus x squared over y, right? Dividing by y because that's my common denominator. And then I'm multiplying this by 1 over y squared. Okay, that's representing that dividing by y squared. It's just easier to look at it like this, right? This is also like the multiplying by the reciprocal idea. Now, we are nearly there. We could just combine this and have negative y squared minus x squared over y to the third. But here is something cool about some of these conic sections. Where do we see something that, where do we see something that looks like this, negative y squared minus x squared, somewhere else in the problem?
That equals negative 25.
Good, because negative y squared minus x squared is negative times x squared plus y squared. We are told that this equals 25.
Oh my. Wow. That came around.
There's your answer. Because if it's negative times x squared plus y squared, that's going to turn to negative 25. Y times y squared is y to the third. So indeed, we have written the second derivative in terms of x and y. It just so happens it is just y. The other thing that is cool is here. I told you yesterday that the second derivative deals with concavity, right? It's the change of the rate of change. This is a circle. That looks like that, right? So radius of 5, centered around the origin. So what this is telling me, what this equation tells, what this second derivative tells me is that the concavity is solely based on the y coordinate. Look at the bottom of the circle. What types of numbers are the values of the y on the bottom half of the circle?
Negative.
They are negative. So if I have negative 25 over a negative value to the third, it is negative over negative, right?
Yes.
What's negative divided by negative?
Positive.
Positive. What type of concavity is the bottom half of this circle?
Concave up.
Concave up. So that tells you that when a second derivative is positive, it's concave up. What type of y values are on the top?
Positive.
Positive. Negative 25 divided by a positive value cubed, it's negative over positive, which is negative. So it is concave down. So when a second derivative is positive, that part of the graph is concave up. When it is negative, it is concave down. Hold on to that for Unit 5. Alrighty. Okay. There we have it. Alright. So, the rest of your time today is time for you to work. So, with our quiz tomorrow, the quiz tomorrow is over inverses. So, the flipping the x and y, using implicit differentiation. Your quiz tomorrow will either have an inverse sine or inverse tangent. That is the only thing I will ever test you on, because that is what comes up on the exam. So I have a small set of problems I'm going to give you. Some of them are multiple choice. I have made this available also online for you to be able to check your answers. Do that. So down to you. So remember, you do not need to turn this in. You just have the option of submitting your answers online. I do know that all of you are here.
Bye, Aaron.